I'm just creating a second video explaining ionic bonding because I was checking your work and I have realized that you're still having difficulties with ionic bonding. When an ionic bonding is taking place, when you have a metal combined with a non-metal. When you have a metal combined with a non-metal. And why an ionic bonding is going to take place? Because the tendency of the metal is just to lose electrons, while the tendency of the non-metal is just to accept those electrons. That attraction force between a cation, which is a positively charged ion, and an anion, a negatively charged ion, that force of attraction is what keeps these atoms together, and the metals and the non-metals, they become more stable because they are reaching, or they have reached, the octet rule. You know that the octet rule is when the elements reach chemical stability by losing or gaining electron to reach the electron configuration of a noble gas. In other words, a electron in the last level of energy. Here in this example, you have lithium combined with sulfur. Lithium, you know that is in group 1. So if lithium is in group 1, lithium only have one valence electron. And you know that the electron dot diagram is a representation of the valence electrons using a dot plus the symbol of the element. So all the elements located in group 1, they have only one valence electron. And that's why they have similar chemical properties, because of that one electron in the last level of energy. Sulfur is in group 16. Okay, so it's 1, 2, 3, 4, 5, 6. Miramos y why like that and not like this. Okay, in this one we have also 6 valence electrons, because if you do that, see, if you do the electron dot diagram this way, that means that this pair of electrons, they are not ready for bonding, which is not true. Okay, this pair over here, we call that lone pair. They are not ready for bonding. This pair over here, they are not ready for bonding. But these two over here, those are the two that are ready for bonding. And that's why you have to start 1, 2, 3, 1. See, that's why you have to start 1, 2, 3, 4, and then to complete them with the rest of the electrons. Okay, because if you put them in pairs, that means that they are not ready for bonding. Once that you have, okay, the electron dot diagram, you have to analyze. Lithium is a metal, so lithium, instead of accepting 7, is going to let go that 1, and it's gonna become a cation. Now has 1 electron less and becomes a cation by, losing that electron. For sulfur, in order to reach the octet rule, it needs 2. So it's gonna accept 2 more, and the tendency of the non-metal, I explained that in class, I don't know how many times, it's just to accept electrons. Okay, so they become negative ions. See, in this case, sulfur is accepting 2, negative 2. This drawing that you have over here is what we call the Lewis structure for ionic compounds. I've been looking at your work, and then you are tracing lines, sharing electrons. That doesn't happen in ionic bonding. See, they are not sharing electrons. The metal is losing, the non-metal is gaining. And that's why we have over here the oxidation number. Oxidation number. And that oxidation number is the share of the ion after losing or gaining electrons. The positive one is the cation, and the negative one is the anion. Why are these two numbers important? Because when you are writing the chemical formula, you have to switch them. Remember that? You have to dance, baby, dance. That 2 is gonna come over here, see? 2 down the lithium And the 1 is going to be down the sulfur, but since you have a 1 over here, you don't need to put that over there, because by putting the symbol of sulfur, that means that you have 1 atom. Okay, so you go from the number or the oxidation number all the way through the number of atoms that are involved in that ionic bonding. This is called, okay, that number over there, see that number under, see the oxidation number there on top, and they have a sign. This number over here under the symbol is called a subscript. And it doesn't have a sign. Okay? You think about that. We are talking over here about matter, atoms that are involved. Can you have -2 atoms? That's impossible. Okay? So that's the chemical formula. If the chemical formula is coming from the oxidation number, how are you going to name that compound? The cation never change the name. Never. Lithium. Never change the name. And later you will see that the cation is the first one, because the cation is the atom with the smallest electronegativity. You remember that when I was explaining periodic trends, electronegativity, when you're moving in a period from left all the way through the right of the periodic table, the electronegativity is going to increase. Now the anion, they change the name. Okay? S is sulfur. S-2 is an atom of sulfur after gaining 2 electrons. So sulfur become sulfide. So you're gonna drop the ending of the element's name, and you have to add over here IDE. That's what happens during an ionic bonding. This is another example. And one more time, when you are completing a test about this topic, I'm going to give you a periodic table. Because if you don't know the position of the elements in the periodic table, it's impossible for you to do this. Barium is a metal. When you look at the periodic table, you will see that it's located in group 2. Alkaline earth. 2 valence electron, 1 and 2. Because they are ready for bonding. If you do this, that's wrong. No, that's wrong. Because that means that it's not ready for bonding. See? The non-metal that you have involved over here is nitrogen. In nitrogen is in group 15. Forget about the 1, 5 valence electrons. 1, 2, 3, 4, 5. See, that pair is not ready for bonding. That lone pair is not ready for bonding. So barium is the metal, always positive. So it's going to lose 1 and 2 plus 2. It doesn't see the oxidation number. See, simple. Nitrogen is the non-metal. You will see that in the periodic table. It's not that complicated. But instead of losing the 5, it's going to gain 1, 2, 3. So negative because it's a non-metal, 3. And this is the Lewis structure for that ionic compound. Now, when you're writing the chemical formula, you're going to switch. You dance, baby, you dance. So you have B, A, 3, and 2. Miramos, the numbers that are under the symbols or the subscript that you're using are going to change the name? No, because you're naming ionic compounds. And when you are naming ionic compounds, you don't use prefixes because you're all confused with the covalent compounds. So the cation, the positive one, doesn't change the name. Barium. And now you have the anion, nitrogen. Okay? N. Now, N, -3, that's not an element. That's an ion. Nitride. See that? Drop the ending, adding IDE. Nitride. One more time. I'm not explaining that anymore because it's all the same, more and more the same. If you don't want to learn this, is because you don't want to pay attention to the video that you're watching, because this is so simple. Yeah, I don't know, you realize that I'm using only, see, I'm not using transition metal. I'm using only metals that are in group 1, 2, and 3. Because those are the representative metals, the one that follow the rules. Let's gonna call them like that. Aluminum is in group 13. 1, 2, 3. Okay, and I have chlorine that is in group 17. 1, 2, 3, 4, 5, 6, 7. So 13, 3 valence electrons, 17, 7 valence electrons. So I have aluminum that is a metal, so positive. 1, 2, 3, so it's losing 3 electrons. And then I have chlorine, which is the non-metal, negative. So one more over here to reach the outer rule, -1. Oxidation number, and then I'm gonna dance, baby, dance. So I have aluminum. I don't have to put the 1 over here, see? And I have Cl, 3 over here, and that 3, you know that is coming from the oxidation number. You don't have to put the sign. So you go from the oxidation number to the number over here, to the number of atoms that are involved. Amy Ramos, what do you do with that information? It's just for you to know that for one atom, or from one cation, okay, of aluminum, you need 3 anion of chloride just to form that ionic bond. How are you gonna name that? Cation, never. Aluminum, never change the name. Anion, you're gonna drop the ending, and then you're gonna add ID. I'm not gonna explain the rest because the rest is more of the same. Okay, it's more of the same. My advice, take a look at this and then try to do the last 2 by yourself.